Hi there, Mr. Sutton with a lesson on hyperbolas. In this one, we'll learn how to graph hyperbolas that are centered on the origin. Before we graph these things, we should probably identify some hyperbola parts. So what is a hyperbola anyway? A hyperbola is all the points with the same difference in distances to two foci. So here's a hyperbola, here's two foci. Every single point on this hyperbola, if you subtract the distances to the two foci, it's always the same. This is kind of like an ellipse where you had the same sum in distances to each of the foci, but it's now differences. There's still a center that this thing is focused on here. We'll call that h comma k. And just like the other shapes here, just like the ellipse, we have vertices, but these are now the turning around points for each branch. So here and here on this particular hyperbola. And the major axis is the axis with the branches. So in this case, this would be major axis x. Now, just like ellipses, we use A, B, and C. A is still the distance from the center to a vertex. B is now the distance from the center to, well, it's kind of floating in space. You could think of there as being kind of an invisible covertex there that's not actually on any of the hyperbola curves for now. And then C, that's still the distance from the center to a focus. One other feature hyperbolas have that ellipses do not is they have asymptotes. So these are the dashed lines that the branches are approaching but never quite crossing. See, we get closer and closer but don't actually get there, and they're diagonal asymptotes for this. Now, these lines, these dashed lines, these asymptotes, it turns out they go through the corners of an invisible box, and that box is as far away from the center as the A value and the B value. Watch this. So if you draw the box, it turns out it goes up, down one of your A or B values, depending on your major axis, and left, right the other value. So there are a lot of commonalities with ellipses in terms of what we name things, but clearly this looks very different. It might help to think of this as an inside-out ellipse as we do these. Let's take a moment to talk about hyperbola equations now. Like the ellipse, the hyperbola equation always equals 1. Unlike the ellipse, however, a squared is not always going to be bigger now. The a squared term instead is always going to be the positive term, which we usually list first. Now, if we're talking about positive terms, yes, that means there's going to be a negative term in these. So let's take a look at major axis x. That's our left-right hyperbola that we actually looked at on the last slide. This one is going to have an equation as follows. So we're still going to have x minus h and y minus k squared. This time, though, a squared is going to be in the positive fraction. So this is major axis x because the x's are coming first with the a squared here. Note that we have a minus now instead of a plus. Note that the minor axis is now the second negative fraction. We can also talk about asymptote equations for these hyperbolas. The asymptotes are, after all, just lines. So to figure these out, we just need to do a little rise over run reasoning. Major axis x, the rise is going to be this b direction here, the minor direction. So your slope of your asymptotes is just going to be plus and minus b over a, rise over run, with an x next to it, because after all, these are slanted lines. Let's see how this compares with major axis y. So this one, we've got the branches going up-down instead of left-right. And we're going to have a different equation now. This is all going to be the same except that the y's are going to come first over the a squared and the x's are going to be the second negative fraction. For the asymptotes, things are going to be reversed. Now a is the up-down direction and b is left-right. So we'll have plus or minus a over b x. Now for both types of hyperbolas, if you want to find the b value, you can do b squared equals, this is a little different than the ellipse, c squared minus a squared. Notice here that the c value is going to be further away from the center than the a value. So to get a positive value, you need to do c squared minus a squared. If you want to find the c value, you can just add a squared over here and have, well, this should be easy to remember, a squared plus b squared. Before we graph anything, let's do kind of a problem where we find some of the trickier parts of these hyperbolas, foci and asymptotes. To find the foci, we can use c squared equals a squared plus b squared and the major axis variable. So for this one, we've got 49 plus 81. This is a squared. 81 is b squared. That's going to add up to 130. So that means that the distance between the center and the foci is going to be the square root of this, the c value, which we'll just leave as radical 130. Can't really simplify that. That's as good as it gets. Okay. Although actually, if we were going to graph this, we would actually plug that in the calculator, but we're not. Now we just have to figure out what our major axis is. That's going to tell us which variable in our center we have to add and subtract this to. So since x is coming first, since this is the positive fraction, that means we have major axis x. Our center on this is going to be 0, 0. We can tell that because we just have x squared and y squared without any other numbers up there. So that means that the 0 for the x value is now going to be a plus or minus radical 130, and the y value is still going to be 0. And if you wanted to, you could write negative radical 130 comma 0 and positive radical 130 comma 0, or you can just put it in this form. How about the asymptotes? For the asymptotes, you're going to have y equals plus or minus something times x, and it's just going to be the a or b value depending on what your major axis is. So for this one, since we have major axis x, since the y values come second here, this is your vertical. This is going to be on the top of your fraction. So we're going to have the square root of 81 over the square root of 49. Square root of b squared over square root of a squared for this. So that's going to be plus or minus 9 over 7, x. If this had been major axis y, so that the y's came first, then you would have plus or minus 7 over 9. So it all depends on your major axis. All right, it's time to sketch a hyperbola. So we're going to do this one together, then you can try one on your own. First step, find and plot the center. In this case, it's just 0, 0, and so are all the ones we'll be dealing with here. So there it is. Next, identify your major axis and square root the a squared to find the vertices. So major axis always comes first. It's always the positive fraction with hyperbolas. So major axis x for this one. A then is just going to be the square root of 4, so 2. And since it's major axis x, we're going 2 to the left and 2 to the right. All right, next thing we need to do is square root the b squared to get the minor endpoints, which remember are not actually on the hyperbola, they're just kind of placeholders. So that's the square root of 9, which is 3. So we're going up 3 and down 3. After that, we're going to draw our box, and then we can draw the asymptotes through the corners of that box. So first asymptote and then the next one. Now we need to figure out the foci. So let's use c squared equals a squared plus b squared to find that and draw those. So that's going to be 4 plus 9 is our c squared. So we need the square root of 13, which is going to be, calculator time, square root of 13, about 3.6. And that's on the major axis, which was x. Now, it's very important to write that down here because I always forget if I don't write it down. So we're going 3.6 to the left, 3.6 to the right. And now we just have to draw the hyperbola branches. We're going to draw them on the major axis, so left, right in this case, and they're going to go through the vertices right here, and they're going to approach but not touch the asymptotes. So here is branch 1, and here is branch 2. And we've got it. Here's one for you to try on your own. Pause the video and give it a shot. All right, so for our center, we've got 0, 0. So there we are. And then for the major axis, that's going to be y this time because y comes first. It's in the positive fraction. So we've got an a value of 3, the square root of 9, the first denominator. So that means since it's a major axis y, we're going 3 up and 3 down. Minor axis, we've got a b value of 2, if we square root that 4. So 2 to the right, 2 to the left. Draw the box through those points. Draw the asymptote through the corners of the box. And then for the foci, we've got the square root of 9 plus 4, so square root of 13 again, which again is 3.6, just like in the last problem. But this time, because it's major axis y, we're going 3.6 up and down. And then finally, draw those branches. So through the vertices, hugging the asymptotes. Same thing over here. And we're finished. That's it for graphing hyperbolas. Join us next time when we write equations for these. Until then, this is Mr. Sutton signing off.